Welcome to Hartman Math. This is lesson 6.2, special right triangles. There are two of them. So we begin with this situation where we have a right triangle with two congruent sides. So we indicate that with the tick marks. So when we see the mark in the mark, it means that these two sides, and we know that in a right triangle, that means these two legs are congruent. So one is marked as x, and so since they're the same, that means the other would also be the same length as x, and we have this unknown y here as well. And our problem is to, at least initially, solve this for y. So we're going to use the Pythagorean Theorem. We've got leg squared plus leg squared equals hypotenuse squared. X squared plus x squared is equal to y squared. And these are like terms. So we've got 1x squared plus 1x squared. That's going to make 2x squared. And we are solving for y, so we're going to undo the squaring. We're going to square root both sides. We normally, in a normal equation, include the plus or minus, but we are talking about side lengths only being positive. So we're just going to square root both sides, only have the positive root. And then we're going to see if we can simplify this. So we would normally break it down, simplify which part of this is a perfect square. That would be x squared. It says it in the name. That's a perfect square. 2 is not. So that's how we're going to separate it with the product property for radicals. So square root of x squared, that's the perfect square, times the square root of 2, not the perfect square. And the square root of x squared when x is a length, and positive is going to be x. So we get x times the square root of 2. That's the y. We can kind of put that here in our diagram. And our diagram essentially is our pattern for the first of the special right triangles. So let's see if we can figure out what right triangle do we have here. Usually these are named by angles. Since we do have two congruent sides, that means it's isosceles. That also means that we would have two congruent angles, the ones opposite of this. And from our previous lesson, we know that the three angles add up to 180. This one's marked as a right angle, so that's 90. So if they three add up to 180, and that one's 90, these two have to add up to 90. But they're also the same. So if they're the same, we could divide the 90 by 2 and say that each of those has to be 45 degrees. And that's the title of this special right triangle, the 45, 45, 90 special right triangle, which essentially says that the two legs are the same length, and the hypotenuse, without having to actually go through the Pythagorean theorem, is one of the legs times root 2. So if this is known and we want to find the hypotenuse, just multiply by the square root of 2. Or if you knew this, in a 45, 45, 90, you could just divide by the square root of 2 to get back to the leg. So we multiply by the square root of 2 to get to the hypotenuse. We divide by the square root of 2 to get to the leg. Because what we're going to see, what the problems look like, is we'll only have one of the sides, which is different than the Pythagorean theorem problems when we know two of the sides. So with only one of the sides, we couldn't do it with a straight Pythagorean theorem. They have to be special right triangles. So we're looking for, at this point, the 45, 45, 90. Here's an example. Example number 1, solve for x and y. We've got a triangle. Is it a 45, 45, 90? Well, we've got the 90, and we've got a 45, and the triangle sum theorem would tell us that that's also 45. So we do have a 45, 45, 90. One of the legs is 9. That means the other leg is also the same length. It's an isosceles right triangle. Two legs are the same length. And then to get y, we would just multiply by the square root of 2. So y would be 9 times the square root of 2. All right, here's a your turn. Go ahead and pause the video here until you know x and y. All right, one leg is 20. That means the other leg is also 20. we would multiply a leg by the square root of 2 to get the hypotenuse. So the hypotenuse is 20 times the square root of 2. That's it on that one. All right, example number 2. This time we know the hypotenuse. We're going to try to find a leg. It really would not matter which one we're going to go after first, since we know they're going to be the same. So the pattern was, when you know the length of the hypotenuse, divide by the square root of 2 to get the leg. 3 times the square root of 2 divided by the square root of 2. Well, square root of 2 divided by square root of 2 cancels, or you can think of it as 1. 3 times 1 is 3. X is 3. And if one of the legs is 3, then the other leg is also 3. Your turn. Pause the video here until you've got X and Y. By the same reasoning, if we divide 20 root 2 by the square root of 2, we're going to get X is 22. If X is 22, that means Y is also 22. Legs are congruent in this particular special right triangle. Example number 3, solve for X and Y. Once again, we know it's a 45, 45, 90. At a 90, we've got a 45. Once again, we know the length of the hypotenuse. So if we go after either one of the legs, we're going to divide by the square root of 2. Let's take a look at that. Well, that's a little bit trickier than the last one. Can't really cancel anything, at least yet. But we can fix the denominator. We've seen this before in a previous lesson where we had to rationalize the denominator. We fixed the denominator, which is the square root of 2, by multiplying top and bottom by the square root of 2. So we would get 10 square root 2 divided by 2. And that does simplify because 10 divided by 2 is 5 square root 2, and that's our x, 5 square root 2. X is 5 square root 2, y is also 5 square root 2. Your turn. Pause until you're ready. All right, we're going to take 2, we're going to divide by the square root of 2 to get x. Go through the same process. 2 divided by 2 is 1. 1 times the square root of 2 is the square root of 2. X is the square root of 2. So is y. So we're ready for our second and final special right triangle, and you might be thinking, that's not even a right triangle, and you are correct about that. So we're actually beginning with a equilateral, also equiangular triangle. All equilateral triangles are equiangular and vice versa. So all of our angles are 60 degrees, and temporarily we're going to say each of the side lengths is the same, and we're going to call it 2x. And where does the right triangle come from? Well, what we're going to do is we're going to bisect this triangle by drawing a height straight down the middle. And that's going to be an unknown length of y. And if we split this triangle basically into two triangles, that makes this angle 90 degrees. It makes that angle 30 degrees. We've got 30, 60, and 90. And if this was 2x, then that means that this is x. And this is the triangle that we're going to focus on. That's going to be where we're going to go after the y, is within this right triangle. Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. Careful here, as you have to square all of the 2x, not just the x. So when we do that, we get 2 squared and x squared multiplied together, 4x squared. And we're going to try to solve for y, so we're going to subtract 1x squared from both sides. And that means 4x squared minus 1x squared is 3x squared. Square root both sides. We're looking for, is any of this a perfect square? And the x squared is, so we're going to separate it out into x squared and 3 as our factors underneath the square root. The square root of x squared is x. So y is equal to x times the square root of 3. That goes there, and we are going to focus on this part right here. And yes, it is a 30 degrees, 60 degrees, 90 degrees, 30, 60, 90 is this special right triangle. So it's a little different than the one before. We have a short leg, we have a long leg, and we have a hypotenuse. Sometimes the drawings may not be really accurate, so how do we know which one's the short one? The short leg is always opposite of the 30 degree, the smallest angle. So that makes this the short leg. The long leg is opposite the 60 degree angle. And the hypotenuse would always be opposite of the right angle, the 90 degree angle. And our relationship is, and we want to focus on the short leg. This is the most important. So in your problem, you don't know the short leg, you go after the short leg first. It's the most important side. Everything's based off of the short leg. Hypotenuse is really easy. If we have the short leg, just double it, and you got the hypotenuse. Just multiply it by 2. And then if we need to go the other way, it's just, if we have the hypotenuse, go after the short leg first, you just divide it by 2. So multiply by 2, you get the hypotenuse. Divide by 2, and you get the short leg. Long leg is the most complicated one, but we do it based off of the short leg. So if we know the short leg, just multiply by the square root of 3, and you got the long leg. If we knew the long leg, go after the short leg first. Don't worry about the hypotenuse yet. Go after the short leg first. Divide by the square root of 3. And that's our pattern. Focus on the short leg. If we don't know it, do this. Or do this. Get the short leg. Go after that. And then we'll get the last piece. So problems look like this. Example number 4. In this problem, here's our 60 degree. That means this must be the 30 degree because that's 90. Opposite of that is the 5. So in this problem, we have the short leg. So it really doesn't matter which one we go after at this point. We know that the hypotenuse, probably the easiest one, we would just double it. So x would be 10. And then to get the long leg, that's the one opposite the 60 degree, we just take the short leg, multiply by the square root of 3. 5 times the square root of 3 gets us the long leg. But there was really no particular order because we knew the short leg, and that's the most important side. All right, here's your turn. Pause here till you're ready. So here's our 30 degree. 11 is opposite of that. So x would be, you didn't have to do this one first, but that's the long leg because it's opposite the 60 degree. Multiply the short leg by the square root of 3. There's x. Double it, and you got the hypotenuse. Y is the hypotenuse, so double 11, you get 22. That's our hypotenuse. All right, example number 5. This time, our given side is the hypotenuse. It's opposite the right angle. How do we know this is a right angle? Well, that's 30. That's 60. Added together makes 90. 3 of them have to add up to be 180, so that makes that has to be 90. So that's a right angle, even though we haven't indicated it. and opposite of that is the 14. We've got the hypotenuse. So we don't know the short leg. Go after the short leg immediately first. So which one's the short leg? It's the y. It's opposite the smallest angle. So pretty easy to do. To go from there to there, we would just take half, divided by 2. We would get y equals 7. Once we know that, the long leg, pretty easy. Just multiply by the square root of 3, and we get x, and we've got them both. Here's a your term. Thirty's our hypotenuse. Which one's the short leg? Go after the short leg first. It's the x, opposite the 30. Half of 30 is 15. That's our x. Multiplied by the square root of 3 to get the long leg. There it is. Example number 6. What do we have this time? We've got one of the legs. Which one is it? It's opposite the 60, which is the larger of the two acute angles. So this is the long leg that we have. We want to go after the short leg. Anytime we have a missing short leg, go after the short leg. So we want to go after y. So we're going from the long leg, the more complicated one. So we would need to divide by the square root of 3. Let's take a look at that. 9 divided by the square root of 3. Once again, we're going to need to fix the denominator. We're going to need to multiply top and bottom by the square root of 3. So we get 9 square root of 3 over 3. 9 divided by 3 is 3. Square root 3, that's our y. Y is 3 square root of 3. Now we want to go from short leg to hypotenuse. Everything's based off the short leg. Multiply by 2. So multiply by 2 means out on the outside, so it would be 6 square root 3 for our x, for our hypotenuse. Let's finish here with a your turn. Once again, we have the long leg. We want the short leg first. Divide by the square root of 3. We're going to get 21 divided by 3 is 7. 7 square root 3 for x. Double that. Multiply by 2. We get 14 square root of 3 for y. And that's it for today. I'll see you next time.